Okay, here we go. Section 4.2. We're going to talk about triangles again. In fact, this whole entire chapter, we're going to talk about triangles. We're going to talk about the angles inside the triangle today. We mentioned this yesterday, but we didn't officially do it. It wasn't in that section. We kind of made mention of it. You didn't really have to know this fact yesterday to do the problems, but we did talk about this. But now we're actually going to do it for real. Okay, so let's label this triangle. Let's call this ABC. Make it easy. Actually, I'll tell you what. Let's not make it ABC. Sorry if you already wrote that, but let's do this. Let's number the angles in here. Let's call this angle 1, call it angle 2, and call it angle 3. It doesn't mean it's 1 degree, 2 degrees, 3 degrees, obviously, right? So this is angle 1, angle 2, and angle 3. We talked about this yesterday, but do you remember what we said that we could do with all three of these angles? All three of these angles inside of a triangle. We mentioned it just a little bit yesterday. They add up to 180, right? Okay, they add up to 180. Or we say this. This is how we would make it a little bit fancy. We would say the sum of the angles, okay, the sum of the angles of a triangle, of any triangle, okay? It just says of a triangle. Doesn't matter what kind of triangle it is. As long as it's a triangle, the sum of all the angles of that triangle is equal to 180 degrees, right? All right, so we talked about this yesterday, but we didn't really explain why or anything like that. Okay, whoever's whistling needs to stop. We talked about that the fact, we gave that fact that the angles do add up to 180. This is something you've probably learned before. It's not brand new. But what I'm going to do today is I'm going to show you why that is true. Let me give myself a little bit more room here because I want to draw something. So what I'm going to do is this. I'm going to draw a line, not just any old line, but I'm going to be pretty specific. I'm going to draw one that's parallel to the bottom of that triangle. What I'm doing right here is not going to be on a test. It's not going to be on a quiz. I'm just showing you why angle 1, 2, and 3 add up to be 180. Okay? It's basically like a proof. So it's a good idea to write it down because every once in a while, not all the time, but every once in a while, we're going to show you why some of these things are true instead of just throwing them out there and say, here it is, just believe me. This is actually a proof that the angles of any triangle add up to be 180 degrees. All right, so let's do this. Let's number a couple other angles. See this angle right here? Let's call that angle 4, and this angle right here, we'll call that angle 5. All right. What I want to do is this. Now remember, what is my goal? My goal is to show or to prove that angle 1 plus angle 2 plus angle 3 equals what? 180 degrees. All right, so that's what I'm trying to prove. Now I know I've told you that it's in the book and stuff, and you're like, well, we already know it's equal to 180, but I want to prove that it's true. Okay, I don't want to just accept it. I want to prove that it's true, and we're going to use some stuff that we've learned earlier. Remember what I said about this line? That's just not any old line. I made this line what? Parallel to this bottom side right here. Okay, so that's very important. It's important that that line right there is parallel to this one here. All right, and I made it so it was. What I want you to do is take a look at these three angles up at the top here. You see that? The 4, the 2, and the 5. That 4, 2, and 5, what do they form? 180 degrees, don't they? They don't form a triangle, no. They form a what? These angles form 180 degrees or a straight what? Straight line, okay, or a line. They form a line or a straight angle. We've talked about that before. How many degrees is a straight angle? 180, right? Straight line is 180 degrees, isn't it? We've talked about that before. That's old. That's probably earlier in the year. So we said it's 180 degrees. So all three of these angles add up to 180 degrees. So guess what I'm going to do? I'm going to write that down. Watch. So I could write this, that angle 4 plus what? Angle 2. Yeah, it doesn't matter what order, but I'll go in this order, 4, 2, and 5. And what? Angle 5 equals what? 180. Now, those aren't my angles of this triangle. Okay, one of them is, right? But not all of them are. But we do know this. And how do we know this? We know by definition that a straight angle is 180 degrees. So any angles that make up a straight line, that form a straight line, those angles are all going to have to add up to 180 degrees. That's nothing that we have to prove. It's by definition. We already know that that is true. Agreed with that? What I'm trying to do is what? I'm trying to show that angle 1 plus angle 2 plus angle 3 equals 180 degrees. That's where this line right here, this parallel line, comes into play. So if you take a look at this, let's look at, let's get rid of this yellow arc right here. Let's take a look at angle 4. Is there anything in this situation right here that you could probably say about angle 4?
Yes, sir.
Alternate interior angle with 1. Very good. All right, so angle 4 and angle 1 are alternate interior angles. If you got parallel lines, what must be true about angle 1 and angle 4? They're equal to each other. Agreed? So 1 and 4 are equal. You're like, well, how does that help us? Well, it's going to help us in a second. Let's look at something else. Do you see anything else that might be equal here? 5 and 3. Good. So let's mark that. So angle 5 and angle 3, they're going to be equal to each other as well because they're also alternate interior angles. Here's your parallel lines. Here's your transversal. And they're alternate interior angles. So they're equal to each other as well. Everybody with me? Again, how does that help you prove that 1, 2, and 3 equal 180? Well, let's come down here. What did we say was the same thing as angle 4? Angle 1. So guess what I can do? I can replace angle 4 and make it what? Angle 1. Can I? It's the same thing. Substitution, right? I just took angle 4. Since angle 1 is the same thing as angle 4, I can just replace it. I substituted angle 4 with angle 1. Well, angle 2 is the same angle with these 3 as it is with these 3, so I'm just going to write it plus angle 2. Right? I don't have to set that equal to anything. It's equal to itself. What do you think I'm going to do next? Yeah, substitute 3 for 5. That's right, because 3 and 5 are equal to each other, right? So instead of writing plus angle 5, I can write what? Plus angle 3. So guess what angle 1 plus angle 2 plus, see? Those are the same, these are the same, these are the same. So if all 3 of these equal 180, what are all 3 of these going to equal? 180, because it's the same exact angles as you got up here, aren't they? Everybody see that? So look what I just did. What did I just do? I just proved that angle 1 plus angle 2 plus angle 3 equals 180. So I just proved that the sum of the angles of a triangle equal 180 degrees. All right? You don't seem that impressed. I think that's pretty cool, don't you? So now I can actually, we use something that we had learned before, and we kind of, we put our parallel lines here. We knew that these equal 180. We substituted, right? We knew that alternate interior angles were equal. We substituted, and that makes 1, 2, and 3 add up to 180. So that's a proof. That proves to you that the sum of the angles is 180 degrees. All right? Let's do a little example here with that fact. Now, you're not going to have to do that on the test, so I wouldn't worry about that so much. If you didn't understand it, I mean, that's okay. It'd be nice if you understood what we just did, but if you don't, it's not really going to hurt you. But I think it's good every once in a while to show you where these things come from instead of just believing them every single time, just because somebody said. All right, draw this picture. You should be taking notes. You should be drawing this picture right here. Let's mark it up. They tell you what some of these angles are, and they ask you to find some of the missing angles. Everybody should be taking notes. See a lot of people just sitting there with their arms folded, nothing on their desk, no pencil in their hand. Okay, that is not taking notes. All right, taking notes is having a pencil or a pen in your hand, and you're writing down on a sheet of paper. That's taking notes. So everybody should be doing that right now. This is 28 degrees. This little angle right here. This one is 71 degrees. This they put a 2. Does that mean it's 2 degrees? What do you think? It's just angle 2. Right. It's just a name of the angle. And they call this angle 1. They call this angle 3. They tell you that this is 57 degrees. And I think that's all they tell you. Yep, that's all the angles. So what do you think they're asking you to do on this problem right here? Solve for what? What's that? Well, what do you mean solve the triangle? Solve for what?
1, 3, and 2.
Yeah, 1, 3, and 2. 1, 2, and 3. Solve for the missing angles, right? Okay? We're solving for the missing angles. So we're trying to find out what angle 1 is, what angle 2 is, and what angle 3 is. Michael, what do you see right off the bat? Okay. Michael said, I'm going to start with angle 1. Look at angle 1. If you went like this, that's what you saw, isn't it? Okay. If you see angle 1 right there, look at 57. 57 is right next to angle 1, and it forms a what? Straight line. So what must be true about this angle and this angle? They do what? They add up to be 180 degrees. So I could add them up, set them equal to 180, but what's my math involved here? I just do what? That's it.
You just make one
It's not 1 degrees. It's the name.
Why do you make angle 1?
Oh, because it's not 71 degrees. There is a right. The 71 is here. The 71's not there. They're not equal to each other. They're not alternate interior angles. Do you have parallel lines? No, there's no parallel lines. Okay, there's no parallel lines, so this angle is not 71 degrees. How do we find it though? It forms a straight line here, doesn't it? So we just go 180 minus 57, and what's that? 123. So that's this angle right here. So that angle right there is 123 degrees. So when you add 123 to 57, you get 180. All right, so we got one of them. That's one of our answers. That's angle 1. Now we got to find angle 2 and angle 3. Okay, so now we're going to find angle 2. So Calvin said add 57 and 71 together. But is that what angle 2 is?
No.
What would we do after we add them together? Okay, so we take that's 128, right? And then we take it away from 180. I'll show you a little bit easier way. Somebody in my other class just didn't think it was easier, but I think it is. Watch. And that's perfectly fine. You can do that. You can go, add these up, and then take them away from 180. But then you're doing two different math problems, aren't you? You're doing addition, and then you're doing subtraction. Watch what's a little easier. If you want to use your calculator on this, I think it's a little easier to do this. They all three add up to 180, right? So what can I do? I can take away what? 71, and then I can take away 57. Would you agree? So really, you're only doing one thing now instead of two. It's really not that much different. But I just kind of like this. So it's 180 minus 71 minus 57. And I get 52. Right? And you could have added them together and taken away from 180. It's exactly the same thing as what we did right there. I just think on a calculator that's a little bit easier because I do it in one shot, right? I don't have to add them and then take that number and then subtract it. I'm just subtracting them both from 180 and I get 52. So that's that angle right there. 52 degrees. So there we got two of them. We got angle 1 and we got angle 2. What else am I going to find? Angle 3. So how do we find angle 3? And remember, we know this is 123 now, don't we? So what are we going to do? We're going to go 180 minus 123. And then what? Well, not yet. It's not just 180 minus 123. You got to take away this one as well. 28, right? So to find this angle right here, you got to take 180, take this away, and then take this one away. And then you've got your answer. Where's my calculator down here? All right, so let's put that in there. So it's 180 minus 123. Oh, sorry. 180. I put 181. Just missed my button. Okay, minus 123 minus what? 28. And that's 29. All right? So that's 29 degrees. So that angle right there is 29 degrees. And we found all three angles. It's not so hard, is it? Did I do that right?
Yeah.
Yeah, I did. Okay. I want you to see something. This is going to... Where'd that come from? Watch this. Look at this angle right here, this 29 degrees. And look at this one right here, this 28. And look at this 57. Anything in common with those? Exactly right. Look at it. Everybody see this? This is what we're going to get to next, all right? I just want to give you a little sneak preview of what we're going to do next. Look at this angle and look at this angle. If I just added them up, what's it going to add up to be? This angle right here, 57, okay? Let's do it this way. Let's do another color. Watch this. Look at this angle, 123. Do you see anything else that might add up to 123? 71 and what? The 52. That adds up to 123, doesn't it? You see a little pattern developing here? Okay. Just wanted you to see that with these numbers because sometimes that helps, makes things a little easier. So now we're going to show you this. Let's draw another triangle here. And it's going to look like this. Make one go like this, and go like that. You say, well, it's not just a triangle. What's up with this part sticking out right here? Well, if you look at this, See this angle 1 right here? This 123? It's this triangle with this part of it sticking out. Do you see it? So that's what I'm trying to draw. That's what I'm trying to figure out. Inside the triangle, we call those interior angles. So what do we call the angle that's on the outside of the triangle? An exterior angle. So that angle right there is an exterior angle. So at first, this is just a little bit of vocab. This is an interior angle, and this is an interior angle. But here's the story I always give with this. They call these remote interior angles. Why use the word remote? Well, think about a remote control, okay? Probably use a remote control almost every single day. What's the purpose of the remote control? So you don't have to what?
So you get up.
So you don't have to get up. Okay, guess what I did when I was your age watching TV? If I had to change the channel, I actually had to get up off the couch, walk over. I did the antennas too, but I walked over to the TV and I actually turned the knob. And it wasn't like just I turned the knob. It was a big old knob. You got clunk, clunk, clunk. You know, it wasn't like we basically had maybe about 5 channels. We had 3, 6, and 10, and 12. Channel 12 was the public television. Then we had like 17, 29, and 48. So how many is that? That's about 7 channels. That's about all the channels that we had when I was growing up. And you know, actually click the knob, click, 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 and like you'd be on channel 3, but then you have to click it through 4 and it'd be all fuzzy. Click it through 5, it'd be all fuzzy, and then you get 6 and you get a station. And that's how I grew up watching TV. You know, it's not that far in the dark ages, but it's a little different than today, all right? The first time I ever saw a remote control on a TV anyway, I was at my friend's house, and he actually had cable. We didn't have cable. And our friend's house, he had cable, and the box would actually, it had a wire that would attach to the television, and the box was about this big. It was probably not as big as this projector, but it was pretty close to about the size of this projector right there. And on the projector was all these little buttons that you would push down, and one button for each channel. There's probably like 30 buttons on there, because that's about all the channels you got back then for cable. And so if you wanted to change a channel, if you wanted to go to 6, you'd hit the 6, okay, and it would press down. You know, it wasn't like using a remote. And that was the first remote that I ever used for a television. We thought it was really cool. Wow, you don't have to get up anymore. You can actually sit at your couch, if your couch wasn't that far away, right? If the wire would reach, and you could actually do that. But nowadays with remote controls, you can stand the other side of the house, basically, couldn't you? And click the remote and change the channels and everything else. So why do we call these remote? Why did I go through that silly story just to talk about the word remote? Because look at these 2 angles. Look at this angle here. Call this angle 1, call this angle 2. Look at angle 1 and angle 2. They are what to the exterior angle? They're farther away, aren't they? Okay, so when you have a remote control, you're farther away from something, right? You can be far away from the TV and still change channels. So look, this exterior angle right here, if that's where I'm sitting, look where the remote interior angles are. They're furthest away. Is this one remote? No, because it's right next to it, isn't it? It's adjacent to it. Remember that word from beginning of the year? So this is adjacent or next to it. These are your remote interior angles. All right, so why did I mess around with all that? Because if you look at the theorem that we're going to talk about, it uses the word remote interior angles, and that's why I wanted you to know what it meant. Do you remember what we did over here? Let's look at this triangle right here. See this triangle right here? Which one is the exterior angle to this triangle? Angle 1, right, because if I extend this side, angle 1 is the exterior. Which one is the remote interior angles to angle 1? 71 and 52. So what do you do with those 2 to get this? Add them up, okay? So let's think about that. So the exterior angle is equal to what? Just one of them? Both of them do, but what do you mean both of them? You got to add up to, right, they add up. You got to add them both up. What word do we use? What fancy, it's not a big word, it's a little word, but it's, what math word do we use to add stuff up? The sum. All right, so this is what it's going to basically say in the book. The exterior angles is equal to the sum of the what? The remote interior angles. Exactly right. Okay, that's why I wrote all that stuff out, because I wanted you to see that. So it's equal to the sum of the remote interior angles. And that's the way you'll see it in the book. All right, let's make exterior 3. Is that all right? Everybody does that make sense? So if I wanted to write it, instead of writing it like this, what if I wanted to write it just with angle 3, angle 1, and angle 2? What would I write? Which one is the exterior?
Angle 3.
Angle 3. So I would say angle 3 equals what?
Sum.
Yeah, but let's write it as a math thing.
Equals 1 plus 2.
Well, angle 1
Angle 1
plus angle 2. You got it. Make sense? All right, it's the same exact thing. Now, of course, it's not 3 degrees, 1 degree, and 2 degrees. It's just the name of the angles. So if I wanted to find that exterior angle, what do? I look for the remote interior angles, not the one next to it, the two that are further away. I just add them up, and that's going to be this angle right here. It worked here, didn't it? Do you agree? And it also worked. Look at angle, whatever this is, that 57 right here. See that angle right there? That's an exterior angle to this triangle, isn't it? Everybody see that? See this triangle right here? That's the exterior angle to this triangle. So it should work out where these are the two remote interior angles, aren't they? And this is the exterior. So if I add up the two remote interior, it should equal this exterior. Does it?
Yeah.
Yeah, it absolutely does. All right? So it works out pretty nice. So that's very, very helpful. Okay, very helpful sometimes to be able to do that. So let's do an example with that. Let me find which one did they use? Ah, okay, here's a good one. Now this one is a little bit more difficult than just sticking regular numbers in there because you're going to have to solve for x. All right, we'll make it look pretty much the same. There's our exterior angle, but watch this. The exterior angle, they don't just give you just a regular number for the degrees. They call this exterior angle 2x minus 15 degrees. And they tell you that this angle up here is just x degrees, and they do tell you what this one is. That's 50 degrees. Okay? And what do you think they want you to do? Okay, solve for x and find the exterior angle. Okay? Well, think about that. Think about what the rule is. What is the rule we just talked about? The exterior angle is equal to what? The sum of the remotes. So we don't just set stuff equal to each other. What do we have to do first before we set stuff equal? Add up, right. So I got to go 2x minus 15, right? That's the exterior. That's equal to the sum of the remote interiors. So these two angles right here I add together, and I set it equal to this. So what is this added together? It's just x plus 50. That's all I can do. Everybody see that? So that's what we set equal to each other. We take the exterior and set it equal to the remote interior angles. And once we do that, we can solve for x. And once we solve for x, I can find all the angles in here now, couldn't I? So let's solve for x real quick. Subtract x from both sides, add a 15 to both sides, and then that's 2x minus 1x is x. That cancels, and that's what? 65. So x is equal to 65. So that's what that angle is right there, isn't it? So you know that one is 65 because they just call it x degrees. What about this exterior angle?
65 plus 50.
Good, that's the best way to do it. In the other class, somebody said, oh, plug 65 back into this. Will that work?
Yeah.
Yeah, it definitely will. But what do you think the easiest way to find the exterior angle is? Just add these two up, wouldn't you think? Okay, you can do it either way. Let's do it both ways just to show you that it works. So what is 65 plus 50? That's 115. So this angle right here should be, oops, 100 and... Let's try that again. Let's try it again. Make it look a little bit better than that. This angle right here should be 115 degrees. All right? Let's plug this back into here just to make sure it is. You don't have to do it both ways, okay? If I was to do this, I would just add these two up, and then you got this angle right here. That's what I would do. But let's put it in here anyway. It's 2 times x, so it's 2 times what? 65 minus 15. Does that come out to 115? Yep, that's 130 when you multiply those together. Minus 15. What's 130 minus 15? That's 115. So it works both ways, doesn't it? The easiest way definitely was just going 65 plus 50. Wouldn't you agree? All right. What if you wanted to find this angle right here? You could do it a couple ways, couldn't you? Now watch. It works out both ways. This is 115, this angle right here, isn't it? So what do you do to find this one? Take it away from 180, right? Okay, so 180 minus 115 is what? It's 65. Okay, how about that? It's not always going to be equal. Okay, don't. It just happened to on this problem. They're not always going to be equal to each other, but on this one it is. Make sense? Okay. Do all three of these add up to 180? Yeah. 65 is 130 plus 50 is 180. Yep. Everything works out the way it should, so we're good to go. All right. Let's talk about a right triangle real quick here. We're almost done. Let's do a right triangle. We're still talking about the angles adding up to 180, okay? And it's a right triangle if I put that little box right there, right? So I've got a right triangle. Look at this angle and look at this angle. Remember we talked about this yesterday? That you can't have any more than one right angle in a right triangle. You can't have any more than one obtuse angle in an obtuse triangle, okay? But I want to see what these two angles are. If this is 90, these two angles have to be what type of angles? Acute angles, okay? And they're not just acute, okay? They are acute, but they're not just acute. Because if this is 90, what do you think this and this add up to be? They don't have to be 45, but they have to add up to be what? 90. They have to add up to be 90. Would you agree with that? So angle 1 plus angle 2 have to equal 90 degrees. They have to, because this is 90, right? So if these two add up to 90 plus this 90 gives you 180. Make sense? Let's use a word, though. If two angles add up to be 90 degrees, what do we say those angles are? We had a good fancy geometry word. Complementary, that's right. Okay, so here's what the book says. It's kind of wordy, but I think this makes sense. It says the acute angles of a right triangle are, now these are my acute angles, aren't they? 1 and 2. What's always true about the acute angles of a right triangle? They are, what's the word? Complementary. Complementary. Does that make sense? All right. The acute angles means the non-right angles of a right triangle. Okay, there's my right triangle. Are complementary, which means they do what? They add up to 90. So watch this. Just to make this thing a little bit easier for you. Let's get rid of all these arrows and stuff. Okay, what if I made, we'll make this real easy. Let's say this is 30 degrees. That angle right here. And I wanted to find, we'll call it B. I wanted to find angle B. What's the math? What's the easiest, the quickest math that I would have to do to find angle B? That's exactly what I do. That's the quickest. Now, some people would do this. They'd say, oh, I know two angles, so I'd go 180 minus 90 minus 30. But do I have to go through all that? No, because what do I know about the two acute angles? They're what? They're complementary, which means they add up to be 90 degrees. So if I know one angle, the quickest math is just to do what? 90 minus 30. Agreed? And that would be 60 degrees. Simple as that. Make sense? All right. Let's see if there's anything else. I believe that's just about it. There's another example I did in the other class. So wait, let me I don't want to make one that difficult. Let's do this. I'll give you a little thing to do yourself, okay? I know you're tired of just sitting there listening to me, so you can actually do some work here. Write this down, and watch this. This is 148 degrees right here. This is 2x minus 15. We did an example just like this, but I want you to try it yourself now, okay? I want you to find all the missing angles. A, B, C, okay? So you're going to find this angle, you're going to find angle B, and you're going to find angle C. So basically you're solving for angle A, B, and C. But what do you have to solve for first before you even think about solving for the angles? What do you have to solve for? X, right. Solve for X. All right, I'll give you a minute. Go ahead and work on that. Okay, time's up. Let's give this one a shot. Before we even solve for X, we can find angle A, couldn't we? How could we find angle A? Subtract from, that's it. Subtract 148 from 180, because look at this. This forms a straight line right here, doesn't it? See that? So it forms a straight angle. So if I go 180 minus 48, or 148, and so that's what, 32? Okay, so that right there is 32 degrees. So there's one of my angles I have to find. What about solving for x, though? We got to find x, though, don't we? So what do these two do? What does angle B and angle C do to each other? They don't equal each other. Come on, what did we just talk about? We've said this a couple times. All right. They don't equal each other. They add up to be what? To the exterior angle, right? Right here. There it is. See, it's in a box and everything. See it? You add up the sum. You add them up. It doesn't say that they're equal to each other. And that was my big fear, is that you saw this stuff and you just set stuff equal to each other and you didn't know what was going on. You got to know what's going on. The math isn't any more difficult than math we've done in the past. Okay? You can't just set these equal to each other. Not one time did we say they're equal. We said that they add up to be the exterior angle. So let's do that. So it's 2x minus 15 plus x minus 5 equals the exterior, which is 148. And now we do some algebra and you solve for x. 2x plus x is 3x. Negative 15 minus 5 is negative 20, and that equals 148. Add a 20 to both sides, and that's 168. And then you divide by 3, and what is that? What's 168 divided by 3? 6? Yep, 56. All right, so x is 56. But that's not really what I asked you for, is it? I asked you to find these two angles. What would the easiest one be? If I know that x is 56, what's the easiest one? Yeah, x minus 5. So this would be what? 56 minus 5, which is 51 degrees. Okay? So that's what that angle is. So angle C is 51 degrees. Angle B, you could do it two ways, couldn't you? You know this is 32, don't you? And you know this is 51. So you could take them both away from 180 to get this. Or you could just plug in a 56 to this. What do you think might be easier? I think it might be easier just going 180 minus 32 minus 51. Wouldn't you? Because you already know this angle and this angle, right? To find B, you just take them away from 180. So I think that's the easiest way to do it. It's not the only way, but so it's 180 minus 32 minus 51. And that's 97. So that angle right there is 97 degrees. And there is your answer. Simple as that. We good? All right. All right, that's it. Let me give you a worksheet, and then you can work on that tonight.